Fourth grade lesson 2.10, multiply two-digit numbers with regrouping. And this is the algorithm I was talking about that we were building up to so that you could have all those foundational pieces into place to know why this algorithm works and how this algorithm works. This is the one that you'll use for the remainder of the time, and when you're multiplying with large numbers. It's the algorithm that your parents use when they multiply. So as they were watching maybe the steps before, they might have been curious, like, why are they teaching you this? It was the foundational pieces to make this part make sense, so your brain can put it all together and understand why things are happening, and you'll remember it. So here we go. It's going to start off by showing us the model of what's happening, and then we'll get into just practicing using the algorithm itself. All right, our essential question: how can you use regrouping to multiply a two-digit number and a one-digit number? And we use a word problem to unlock the problem. It gives us good practice, right? A thoroughbred racehorse can run at speeds of up to 60 feet per second. During practice, Celia's horse runs at a speed of 36 feet per second. How far does her horse run in 3 seconds? Let's underline the question. It wants us to say how far the horse runs in 3 seconds. And so let's go back into the problem and look at what information is there that is of use to us. How fast does Celia's horse run in 1 second? Oh, Celia's horse ran 36 feet per second, singular, 1 second. So 36 feet in 1 second. We want to know how many feet it runs in 3 seconds. That would help answer our question. They gave us information here about a thoroughbred racehorse running at speeds of 60 feet per second. Okay, but they didn't ask here about a thoroughbred horse and how far it runs in 3 seconds. It's really only asking us about Celia's horse specifically. So, they were trying to trick us. We don't need that information. We just need how fast Celia's horse runs, and then we'll figure it out. It wanted us to underline the important information. We circled it. Is there information you will not use? If so, cross it out. Yeah, the thoroughbred horse part. They didn't ask us about that. They just asked us about Celia's horse. If they asked me about it, I wouldn't have crossed it out. All right. And I'm going to draw the picture because maybe you don't recognize right away that this is multiply, even though they give it to us. But I want to make sure that your brain knows why it's multiply. So if the horse can run the distance of 36 feet, Celia's horse, in 1 second, then in 2 seconds, there's 36 again, and in the third second, there's 36 again. So I could add 36 plus 36 plus 36, but the shortcut for that, or it will be a shortcut for you for that once you get really much more comfortable with your multiplication, is to just say I'm adding 36 together 3 times over, or 3 36s, 3 times 36. We estimate that, round that up. 36 rounds up to a 40, and we can use what we learned in a previous lesson to get an estimate. This starts to get done in your head. Hopefully that's happening faster and faster and starting to happen in your head. 3 times 4 is 12 with a 0 on the end. It should be the product that we're doing here should be that her horse runs somewhere around 120 feet in 3 seconds-ish. Estimate is like ish, 120-ish seconds. All right. Modeled, we have 10, 20, 36, and another 10, 20, 36, and another 10, 20, 36. Now, here's that regrouping part that we're going to see in that algorithm right away. Instead of doing any calculations, it said, whoa, hey, I can put 10 of these together. There's 18 of them here, right? But I could put 10 of those together and send them over to hang out with the 10s over here. So if you look at this algorithm over here, they set it up like you've been setting up 36 times 3. But this time, just like we do in addition, we start in that ones place so that if there's any spillover, it can spill over. They did 3 times 6 and got 18. And right away in their head, they said, let's clean that up and send that over. Clean that up, send that over. And it left us with 8 ones, right? So that's what this is modeling, okay? And then when you're looking at this part, this is where they've got all those 10s. There were a bunch of 10s here. And they said, oh, hey, looky here. I've got 4, 5, 6, 7, 8, 9, 10 of those. Ooh, let's clean that up. And put them all together. And so what that looks like is you did the 3 times 6 and got 18 and carried it over. Then we do the 3 times 3 is 9 plus 1 is 10. And that gives us the answer of 108. So Celia's racehorse runs 108 feet in 3 seconds. Since 108, what happened? Is close to the estimate of 120, the answer is reasonable. Okay, so one more time, just going to show you the algorithm in action. We did 36 times 3. And instead now of saying 3 times 30 and writing that here, and then 3 times 6, writing it here and adding it all together, we're doing that addition together all in one shot. But we have to make allowance for the spillover. So we start with the ones place, just like we do with addition. 3 times 6 is 18. And then we still have to multiply that 3 times 30. 3 times 3 is what we'll do here is the 9, plus the 1 is 10. And there's our answer. That's how those steps happen. And you'll get super fast at using that algorithm with practice. Let's practice some more. So we'll look at the example 2, and this again is just showing it modeled, but once we kind of let our brain see the modeling of it with this sort of thing, we'll move away and go ahead and start going into using the algorithm just on its own. It probably is something that's going to take a couple days of practice to let our brains adapt to it, so please be patient with your brains on the use of this algorithm. But all the pieces we've been working up to will help things fall into place like a big puzzle. You've got all the puzzle pieces, we just need to fit those into place. And so the last piece that we're adding to it is just seeing the model of it so your brain can accept it and say, okay, I see what you're doing there. So if we're doing 8 times 22, first we would estimate it. And again, that estimating should be getting faster and faster, where you can do it in your brain. Round that to a 20. It's closer to 20 than it is 30. And 8 times 20. Well, 8 times 2 is 16 with the 0 on the end. So our answer or product for 8 times 22 should be pretty close to 160-ish. Estimates are like ish number. And if it's somewhat close to 160, we know we've done it. We've probably done it correctly. So here what they've done is they laid out 22 8 times over. This is 22 plus 22 plus 22 plus 22 plus 22 plus blah, 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 8 times. So there's 22, 22, 22, 22, 22, 8 times over. Ignore this for the moment. Okay? And so they did the 8 times 2 part because they're just doing the ones column. So we're just looking at the 1 columns. There's 8 times the 2 ones. So here it all is. And when you do 8 times 2, there's 16 of them. If you count them up, there's 16, right? And so they're like, oh yeah, but in my ones place, all that fits is 9 is the highest. So I'm carrying over just the same reasoning with addition. Oh, it's too full. So we gather up 10 of those and we put them over with the 10s. Put them together. That's where this one came from. And that's what they did right here. They said, oh, 8 times 2 is 16. 16. Just like you kind of did in addition. So it's that same piece. That one puzzle piece is similar to something you've been using very well. Okay? So that's what they've done in this model. They said, oh, there's everything. Oh, and look at there. 10 of these can be carried over and put into the 10s column. Okay, that's what happened here. Then you're looking at over here. So now we're taking these 10s. Here they are down here. And they're counting them all up and they're saying, look at here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. Okay, well, hey, put those all together, right? Send them over to the hundreds column. So we send them over to the hundreds column. And so here's what it looks like in the algorithm. We do 8 times 2 here. This is 8 times those 2 10s, right? 8 times 2 here is 16. I also had that one carryover for 17. That's what's happening here. We just gathered these up and sent them over to the next column. Okay? And it left us with these 7 tens. So 8 times 22 is 176. Since 176 is close to the estimate of 160, it's reasonable. Okay, now that they've explained in picture form what you're doing, what this carryover is doing, and like I said, I think your brain will be ready to accept the carryover because in addition we do that too. So they just wanted your brain to see what's going on. Now that we've done that, let's look at how regrouping works with the multiplication algorithm. All right, on here they're putting pieces together, those foundations we built in those previous lessons to help us out here, to remind us here. They want the estimate here. We did that in, I think it was lesson 2.4 or something like that. Then we're going to use partial products. I think that was lesson like 2.6 or 2.7. It was really introducing to us the fact that we're using the distributive property, splitting the 68 up into 60 plus 8, so that our brains knew why we were doing it this way when we got to this point. So this will be the new algorithm that we will use, and what your parents use, all the adults around you, when they don't have a calculator handy and have to calculate something out. They end up writing it down this way and calculating it this way. So let's go ahead and look through all three. 68, it falls between 60 and 70, but looky there, that 8 makes it closer to 70 than it is 80, that 8 being an up number, right? So we're going to go ahead and round that to 70. Then we can use that very handy dandy skill we had learned. 7 times 7 is, you may have to look on your grid, but we'll work on memorizing that. That should be hopefully by end of year. 7 times 7 is said, and it just spits right out your mouth the product of that. 7 times 7 is 49. With that 0 on the end makes it 490. So whatever our answer is, whatever our product is for this, it should be fairly close to 490-ish. Maybe a little less than that because we rounded up, right? 490-ish should be the answer, just a little under. All right, let's use partial products. This is a good review of what we did in a previous lesson. Partial products, that helped us understand that that distributive property is being used. This is the same as 60 plus 8, right? 60 plus 8 equals 68, all being multiplied by 7, because 60 plus 8 is still 68. And what we started doing is saying, let's take care of this one first, 7 times 60. Well, the 7 times 6 is 42. With the 0 on the end, it is 420. 42 with 1 0 on the end. And then the 7 times 8 is 56. No 0 on the end. And then we would just add that together to get 476. Reasonably close to 490. So that seems like a reasonable answer there. All right, now let's do that same multiplication, but with regrouping now. So that's that, taking that piece similar to what we do in addition. Instead of starting with our tens column, just in case there's spillover, for the same reason we do it in addition, we're still using that distributive property in a way, but instead of like splitting it apart now on paper, we kind of just do it in our minds, and we always start with the ones column first. So 7 times 8 is 56, right? So remember, I'm too full, right? So 9 is the biggest that fits here. So I'm going to go, just like in addition, 56. Okay, everybody good with that? Then, just like I did over here, I'm going to go ahead and multiply this way. Common problem here I see is that people just go, oh, and then the 6. Nope, we still have to multiply the 60 times 7. We're 7 times 60 and 7 times 8. So we still have to do the 60 times 7. So 7 times 6 is 42. But don't forget the 10 rods, the rods that we sent over. So you add those 5 on there. So we have 42 plus 5, 43, 44, 45, 46, 47 that goes there. I'll do that one more time. So we did the 7 times 8 was 56. And then we had to do 7 times 6. 7 times 6 is 42, plus 5 carryover is 47. 476. That's how we tend to do our calculations as adults, and how you'll do it. All the pieces we were doing before was helping your brain make sense of it, because it's pretty confusing as it is, but when you just teach it and you don't explain that I'm splitting apart the 60 plus 8 before you get here, and you're like, oh, you just do 7 times 8 and then 7 times 6, and everybody's brain is like, what? Why are you doing that? Why are you doing that? And so this part was helping you understand why we're saying 7 times 8 and then 7 times 6. Okay, let's practice a few. And this again is that time where it's safe for you to kind of pause it and try it and see where you get stuck or see what you mess up. I see some of you really take advantage of that, and I could see you gaining the understanding of this much deeper than many people who are just breezing through it and letting the answers show up and then just copy it down. So be a learner for yourself. Don't just breeze through just to get it done. Your goal isn't to get it done. Your goal is to understand it completely and make sure you can do it. So this is your chance. Pause, try it, and then unpause once you're stuck or once you have an answer you want to check it. All right, let's go ahead and have a look. On number 1, they want us to use the model to find the product. This is 2 times 36. So we had 10, 20, 36, and 10, 20, 36. Well, how many 6s or how many 1s are there? There's 6 and 12. That we can group together 10 of them. There's 10 of them, and send it on over here. I'll draw that there, like that. So now I just have these 2 in the 1s column. And then over here I have 1, 2, 3, 4, 5, 6, 7 10s. And so there's my answer as the algorithm, because I feel like the more you see it, the easier it becomes. Here's how it looks. I do the 2 times 6 first. So now we're just going straight to that 1s column first. 2 times 6 goes first. 2 times 6 is 12, right? That's what we had there. Carry that 12 over, just like you did in addition. The difference from addition is now we don't just go straight down here. We're doing 2 times that 30 now. 30 plus 6. 2 times 3 is 6, plus 1 is 7. And there it is. Okay? A few more practices. Let's go ahead and do this one. If you think you're ready, pause, try it, and then start again. So to estimate, 42 is between 40 and 50, but it's closer to 40. That 2 is a down number, a stay number, right? So it's closer to 40 than it is to 50. So I'm going to round that to 40. 40 times 4 is going to be, 4 times 4 is 16 with a 0 on the end, 160. That's my estimate. I did 40 times 4. 160. We round it because this is a calculation that pretty soon you'll easily be able to do in your head, especially if you know your multiplication facts. That's going to make the big difference for you. All right, now we'll find the actual product of 42 times 4 using that standard algorithm that you will be using all the time now. We're going to do 4 times the 2 first. This is 40 plus 2. We'll do the 4 times the 2 first in case there's any carryover. 4 times 2 is 8. And 4 times 4 is 16. And that is my answer. Reasonably close to my estimate, right? Okay, maybe it's getting closer to making sense. Let's do another one. We're going to do 32 times 2. First, we will do the estimate. 32 is between 30 and 40, but that 2 means it's closer to 30 than it is to 40. So we will call that 30 times 2. 30 times 2. And 3 times 2 is 6 with a 0 on the end. So our estimate is 60, meaning whatever our product is, it should be 60-ish, close to 60. If it is close to 60, then we can feel comfortable that we did it correctly. We're going to go ahead and take this 2. Remember, this is 30 plus 2, so we have to multiply 2 by both of those pieces. So that's where it's different from addition. So 2 times 2 is 4. No spillover necessary. And 2 times 3 is 6. And that answer, that product, is close to 60, so that's reasonable. Let's do the estimate here. We have 81, which is going to fall between 80 and 90, but that 1 is a low number, a stay number, so it's going to round down to 80 rather than go up to 90. So for the estimate, I'm doing 5 times 80. Well, 5 times 8 is 40 with that 0 on the end. My answer should be somewhere close to 400. All right, now let's do the multiplication to find the actual product. This is 80 plus 1. We have to do 5 times the 1 and 5 times the 80. So we're going to do 5 times 1 first in case there's anything that needs to carry over or regroup. 5 times 1 is 5. Fits just fine, no problem, no regrouping necessary. 5 times 8 is 40. Since there's no other column here, I can just put 40 down here. The answer 405, which is reasonably close to our estimate. And finally, we have 63 times 7. We'll do the estimate first. This number is between 60 and 70. That 3 makes it closer to 60. It's a stay number, right? Makes it closer to 60 than it is to 70. So we're going to do 60 times 7 for our estimate. 7 times 60, or 7 times 6 is 42 with a 0 on the end. Estimate is 420. And then we're going to use our standard algorithm for multiplying. This is still 60 plus 3, so we have to do 7 times 3 and 7 times 60. So that's why we have to go the 7 times both of those numbers. We'll do the 7 times 3 first in case there's any spillover. 7 times 3 is 21. Clearly that's too big to fit here, so we will split it apart. 21, carry it over. Now we will do 7 times 6, because that was 60 plus 3, so 7 times 6 is 42, and then you add the carryover on. 42 plus 2 is 44. And that is the answer to this one. That's the product. Very close to 420, so this was a reasonable answer. If this is making sense to you, fantastic. You may be ready for Think Central. If it's not, normally I don't do the on your owns on the page, but I'm going to choose to do maybe 2 or 3 more for anybody who wishes to have a little more practice with me before doing the Think Central. And then if that's not enough, of course, then we'll work together in class to practice a little more. So you can leave the video at this point and go on to Think Central if you're like, no, I totally get this. Or you can continue with me for just a few more for a little extra practice. And you can do this one in the same way. Try it, pause the video, and then see where you get stuck, or see if you want to check your answer. You can do this one in the same way as we did before. We have 33 times 2. Let me get the estimate first. 33 is between 30 and 40. That 3 is a lower number, so it's closer to 30 than it is 40, so I'm going to call it 30. And multiply that by 2 for my estimate. 2 times 3 is 6, with the 0 on the end, that's 60. We estimate because it's quick to do in our heads. Now let's find the actual product. I'm going to do remember 33 is the same as 30 plus 3, so I'm going to multiply 2 times 3 and also 2 times 30. 2 times 3 is 6. That fits there just fine. And 2 times 3 is 6. And my answer, or my product, is 66. Reasonably close to 60. Next one, 25. 25 is right in the middle of 20 and 30. That 5 is an up number. When it's right in the middle, we round up. This is going to be 30 as a rounded number to do our estimate. 30 times 3. 3 times 3 is 9 with a 0 on the end. Our answer is going to be close to 90-ish. Rounded up, so it's probably going to be a little smaller than that. This is 20 plus 5. So we need to multiply the 3 times both of those numbers. 3 times 5 is 15. And 15 is not fitting here, right? So carry it over just like we did with addition, 15 like that. Then we do 3 times 2 is 6, plus 1 is 7. And 75 is reasonably close to 90. We know we went up several numbers, so that would be why that is a little bit different. We knew it was going to be under it too. 36 times 8. We'll do the estimate first. 36 is right in between 30 and 40, but 6 is a higher number, so we're going to round up to that 40. It's closer to the 40 than it is to the 30. And we'll multiply that times 8. 8 times 4 is 32 with that 0 on the end. So whatever our product is, it should be somewhat close to 320. A little lower than that because we rounded up to 40. So it'll be a little underneath that. Remember, this is 30 plus 6, so we need to multiply 8 times 6 and 8 times the 30. But we start here in case there's any spillover. 8 times 6 is 48. Definitely does not fit there, so we're going to do 48, like that. 48. Carry over. Then we do 8 times 3 for this one. This is the 8 times 30 part of it, right? 8 times 3 is 24, 25, 26, 27, 28 to add that 4 in there. So it was 24 plus 4, which is 28. Not too far off. This is nearly at 300. This is just over 300. And we knew it would be a little lower. So this is reasonable. Okay, I'm hoping you're feeling like you're getting the hang of this now. 94 is just between 90 and 100. That 4 is stay number. It kind of keeps us down in that 90 range. So we're going to round that to 90. That'll be times 5 for the estimate part of it. 9 times 5 is 45 with that 0 on the end. So whatever our answer is, it's going to be close to 450. Since we rounded down, our answer is probably going to be a little higher than 450. This is 90 plus 4, so we have to do the 5 times 4 and the 5 times 90 to get our calculation. 5 times 4 is 20. That doesn't fit there, so carry over 20. 20. 5 times 9 is 45. Then add that 2 on there, 47. 45 plus 2 is 47. And there is your answer. Just a little bit over, like we expected. Reasonable. Hopefully those extra problems were enough to get you thinking maybe you can do the Think Central. But please don't worry if it's not. I will practice some more with you in class. So if you need more practice, we will do it. Probably will do it even if you don't think you need more practice, because I want to make sure you have this solid.